Over to you, David.
Cool. Well, first of all, thank you everybody for taking time out of your week. I know this is Microsoft Ignite, it's supper time, there's always a lot going on. This is 10 cloudy questions to ask before migrating your SQL Server. A little bit about me. I am a certified nerd. I'll be the first to admit that. And if you look at my video here, you'll notice I'm working on the Frovid-19. So bear with my appearance. I need it to grow a little bit longer so I can pull it back, and then I'll look somewhat shoveled again. So like I said, my name is David Klee. I actually run two companies now. Primary company is a company called Heraflux Technologies. We do consulting around how databases and the infrastructure underneath it work together. The other is a company we actually just launched called Sequilibrium, and it is, go figure, how SQL Server and the infrastructure underneath it work together, but online, self-paced training videos. We just launched that actually about 3 weeks ago. Been having a lot of fun with it. The first course that we put out is SQL Server on VMware performance and availability tuning. It does apply to VMware on the cloud. I've got another one in the works for Hyper-V. We're going to work on cloud IaaS underneath SQL Server, and then a SQL Server on Linux course here pretty soon. You can kind of tell I am a absolute nerd with this stuff. I'm lucky enough, like Vaibhav, to be a Microsoft Data Platform MVP. I'm also a VMware V expert. I try to blog when I can. It's never enough. You can find me with contact information up here. Probably the easiest way is with Twitter, just direct message or messaging on LinkedIn. I see that pretty frequently. Okay, so this session is titled 10 Cloudy Questions Before Moving Your SQL Server basically to the cloud. With this being the Azure group, I'm going to kind of gloss over a little bit. You already know what the cloud really is, but you also know that your SQL servers are amongst the most aggressive machines in your environment. And on-prem, in the cloud, whatever. These are the things that eat a lot of CPU. They eat a lot of memory, a lot of storage, both in terms of capacity and demand. And what might work for a general purpose app server or file server, domain controller, things like that, it may not necessarily work from a database perspective. And the challenge here is we have a lot of options from a database perspective with how to actually start to use this stuff in the cloud. So I designed the session to be more like a 101. You're looking at moving this stuff to the cloud. What do you ask? What can you figure out up front before you start, hands on a keyboard to figure out, is the path that I'm prepared to go down the right path? Or what are the paths? And then because the database licensing is so pricey, that contributes to a really high amount of the cost in the cloud. That is an area that I focus on, really cost management. Fun part is it doesn't just apply to the database engine, it really applies to everything. So let's get started. So this is 10 questions, but I start with 0. And this, just to get everybody on the same page, I always say, what is the cloud? And it's a pretty ambiguous question because quite frankly, if you ask 10 IT people what the cloud is, you're going to get about 14 different answers. So my take on it is that there is no cloud. It's just somebody else's data center. And when I look at it that way, it literally is Microsoft or Amazon or Google or Oracle. It's just their cloud. It's their data centers with some really good virtualization and some amazing automation. It becomes a self-service platform. They provide the infrastructure, they provide the automation, but now I can use it to do what I need to do. And that's really cool because if you've ever tried to do anything in your on-prem data center, you put in a ticket or request for them to do things and they'll get to it eventually. Here, it really moves at the speed of your request and their automation. The cool thing about it, because the automation is so significant, it gives us the ability to not just use servers out there, but now I can selectively expose certain pieces of these things, different applications, different functionality, but I can abstract the rest of it. This gives me the ability to do things like not have to worry about patching an operating system or migrating a service or a platform from X to Y location or be able to back it up easier, things like that. We'll talk about the database specific ones here in a few. Now, definitions, just to make sure we're all on the same page. I know a lot of you may not be database administrators, so I'll make sure to translate this stuff. The way I look at it, infrastructure as a service, or IaaS, is simply a virtual machine. So it's a copy of Windows or Linux running in a container, essentially a bucket of compute resources in the cloud. You have storage, you can back it up, you can move it from point A to point B, but whatever's in there is yours. You have to maintain it and manage it. In this case, I can install SQL Server in an Azure virtual machine just like normal. Platform as a service, or PaaS, is essentially, I'm going to keep the database engine, but I'm just not going to worry about the operating system. Azure has a really good platform that they call SQL Managed Instance. And I use this personally for some of my production servers. It works great. It's not quite the cheapest, but I get all the functionality of a regular database engine, just I don't have to patch servers. And quite frankly, I don't know about you, I'm 41. I've been patching servers since I was 15. I'm tired of managing the OS. I'm just done with that. Now, if your database workload will allow for it, you have a database as a service, or DBaaS, and Azure's got an Azure SQL database, and we also use this, and it works really well when it's the right use case. The way I look at it, these give you three flavors of the same thing, just different layers of automation, different levels of access. You can or can't do certain things depending on what you can't get to. Major cloud players, I would not be doing due justice if I didn't highlight that Azure is not the only cloud provider out there. My personal pick is Azure, and this includes my production environment, mostly because, quite frankly, I like it. To me, it's easier to use than some of the others. I find that the performance is a little more consistent than the others, and the price is just a little bit better. Doesn't mean the price tag is great, but I use it personally. I recommend it to all my customers. If you're looking for impartiality, quite simply, these all work. If you're looking at doing anything in the cloud, pick the pros and cons with each of these, weigh them side by side, make sure they work for you. I don't have anything against these. I just like Azure because I find it a little bit easier to use. Now, you'd be amazed at the amount of people when I say, "Where is the cloud?" They go, "I don't know, it's magic." It's like, no, it's on land. If you look at any of the major cloud providers, and this one is highlighting Azure, of course, this is a map of all of the data centers that Azure listed as of about a month ago. And you'll find that these are basically groups of data centers all around the US. The central US is in Iowa, North Central is near Chicago. West US 2 is near Redmond, and you can start to pick and choose, because if you're looking to get data closer to either your users or your customers, you can actually selectively pick certain data centers to get the data closer to them. And that's really, really powerful, because less latency means better performance. And conversely, if you're looking for disaster recovery, let's say I am concerned about hurricanes. So would you want a DR site? If your primary is in East US, would you want DR in East US too? No. You'd probably want Central or maybe West Coast. Pick a different set of geographic issues at that point. But it's cool, because now certain locations, like we do a lot with the EU, there are a lot of laws in the EU pertaining to keeping your data in your own country. So I know Mexico has that, and Denmark has that, Germany's got that. So there are just a lot of these data centers popping up all over the place. So it's cool. You basically just pick from a map and go. It's awesome. Okay. Step number one, and feel free, throw any question out there. I don't want to move on unless I've answered everybody's questions with this stuff. Now, step number one here. Why are you considering moving your database servers to the cloud? And I'll be really specific with that. How many? I wish I could do a poll in here, because I'd love to know, for those of you that are either moving to the cloud or already all in, why did you go? No exaggeration. I have had C-level people just say, "We're going, drop everything now, go, 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 go. We're in, we're going to be there in a year, go." And yeah, exactly. Now, did they give a legitimate reason?
You can ask people to raise their hands if you want to get a poll done.
Cool. So yeah, actually, let's do that. How many of you, your organization had what you would consider an illegitimate excuse for going to the cloud? Either your CEO read it in a Sky Mall magazine, or just it didn't really make business sense to consider it. Yeah, got a few. So that's cool. Yeah. You'd be amazed the amount of people that I find that have, business will, but not really the technical reason to go to the cloud. It's kind of scary because if they just say go, the amount of planning that goes into it to actually determine what and when and why, it's a lot of times missed or it's rushed. And you end up backing yourself into a corner that's not the most fun. No exaggeration. I have two companies. They literally read about it in a magazine on a plane. They came back the next day and they said, we're moving to the cloud. Go. It's crazy, but this is real. So I always tell people cloud is a phenomenal use case when it's the right tool, but we do try to stay impartial. We don't resell equipment or hardware or software or anything because we want it to be the right platform. Pick all the reasons why you want to move to the cloud. Compare and contrast these with the negatives for going to the cloud. There's got to be good business reasons. Public cloud is fantastic. If you've got an established relationship with the regional colo, maybe they manage your platform for you and they provide the capabilities that you need with the infrastructure that you've got, maybe it'll be worth staying with them. Or maybe we can selectively move certain services to the cloud. We don't have to move everything. Cloud gives you great automation. It really, really does. I love it. The business, though, has to benefit. What can the business gain by having a competitive advantage with the cloud? And it is a business decision. It's not just a technical decision. You have to be able to quantify those. And by quantify, I mean, what's the ROI? What's the amount of spend? What do you get in return? How much staff time do you save? That sort of thing. Can your business monetize those? And that's a big one right there. What do you get by doing this with the cloud? It's not just a technical change. This is an IT-centric discussion, but it's not an IT-driven decision. The business has to benefit from it from a whole. And you as a technologist, it's worth it to you and your role to actually bring these questions up because a lot of times, let's just be frank, a lot of time IT is looked at as a necessary evil and a cost sink to the organization. And that's just the nature of the job. We are the silent people that keep the business running. The hard part here is when they make these calls, what's in it for them? It's a crazy amount of work for you, but what's in it for them? The business has to be aligned with this. And in some cases, when I say aligned, there might be practices and processes that need to be adjusted in order to work better on the cloud. They have to be aligned to this. Cloud is simply a means. It's just a platform. Just like virtualization, physical machines, all the stuff on-prem, it's a means to power business critical applications to power the business. How do you measure what you're getting out of all this? And these are tough questions. Most of these are rhetorical questions because most of the time when I talk to folks, they don't have answers for this stuff. It's tough. The other part there is how much technical debt do you have in your environment right now that you have to manage? Is a move to the cloud the right time to start reviewing some of the technical debt to figure out, can we modernize some of this stuff? Can we leverage some of the cloud platform providers to actually make improvements by either simplifying things or increasing the runtime of it or decreasing the cost of it? This is the time to do it. Because if you have a lot of just awful code and you just lift and shift it to the cloud, well, you've still got a mess. You still have got a massive problem that you have to deal with. It's just now somewhere else. There's a lot of mess with the cloud. There's a lot of benefits to it. A lot of people think that moving to the cloud is all or nothing. And I'm sorry, but nothing could be further from the truth. Especially if you've kept up with the announcements from Ignite this week, Azure Arc is amazing. It literally gives you cloud automation on-prem. It's fantastic. There's a lot of myths that the cloud is cheaper. And I'm sorry, but it's not it is cheaper, yes or no answer. There is a lot of gray areas in there. Cloud can be cheaper if you can strategically modify some of your processes and your tasks to leverage some of these things. But in other cases, I deal with database servers that are $250,000 a pop. They're not cheaper in the cloud. They're cheaper on-prem. If you have the staff, and if you have the footprint, and if you have the data center space and all this stuff to go maintain this. And then there's my personal favorite, all the subjective comments. It's better. No, cloud is different. Cloud has advantages. Cloud has disadvantages. Don't just say it's better. Tell me why. Other mostly C-level people think the cloud means no maintenance. No, you still got to maintain some of this stuff. A lot of times, maybe we can buy a service that has the patching of the underlying operating system taken care of for you. Great. You still got to maintain the application. You still have to work around when they do maintenance. All these things you got to worry about. Or my personal favorite, it's easy. No, it's different. There are some things that are more streamlined. There are other things that might be a little more challenging. It's just different. The other thing makes things faster. This is another one of those subjective areas. If you've got a multi-million-dollar mega data center and you're looking at going to the cloud, there's a high likelihood that it's not going to be faster if you just lift and shift without modernizing anything. If you got a 10-year-old piece of junk environment that's barely inching along, yeah, it's probably going to be faster. But what do you need? That's the tough part. And then my favorite, guaranteed available. Now, we're all cloud professionals here. Just hit your favorite search engine and look for cloud outage, and you're going to get about 10 million hits on that. Cloud is not guaranteed available. Depending on your on-prem platform, cloud might be more available than what you're coming from. In other cases, it might be less. It's up to you. It's up to you to figure out those SLAs. So I'll talk more about that here in a little bit. And then my personal favorite, again, everyone's doing it. No, everybody should be looking at the cloud at this point to figure out if it's the right tool to incorporate into their toolbox for their business. But not everybody's moving to the cloud. We have a lot of customers, a lot of friends that are still on-prem, and they love it. It's the right tool for what they're trying to do. But again, you don't have to be all in. Now, cloud migration facts. It is incredibly flexible. The customizing and the automation in the cloud is amazing. You've got all the automation in the world, and if you can dream it, there's probably a cloud service that can do it. So if you need that level of flexibility, the cloud's got it, and it's probably going to move faster than your on-prem data center. Security, data protection, compliance. I talk about this in a little bit, but your practices on-prem are, quite frankly, on average, pretty poor. Most things are wide open until you lock it down. In the cloud, it's so tight that you have to open it up just to be able to get to it yourself. And that's actually a good thing. It makes more work, but it's there. Other areas of the cloud, you can actually buy cloud platforms that are PCI compliant or healthcare compliant, things like that, where you basically audit all the holes that you've poked in all the security, and that becomes your audit, and you can start to figure out, am I more secure than I was on-prem? A lot of times you'd be surprised, but you would be. Application and data center modernization. I talked about this a minute ago. The cloud is going to give you a lot of options for really improving some of the legacy practices, be it moving data around or transforming it or warehousing it or mining it with machine learning. You can start to use a lot of these services rather than having to construct your own mechanism to do this. And that is incredibly powerful. Again, if it's the right case and if your organization is willing to give you the time to do that. The speed of performing IT operations is a massive one. I got one customer right now, no exaggeration. I need them to build out literally a single virtual machine on-prem. I've been waiting 4 months. You want to go build a VM in the cloud? Take about 5 minutes tops. The speed of performing IT operations in the cloud is quite literally at the speed that you can click through or script through a build wizard and a couple of minutes for them to implement it. It's not bad. It's probably better than what you've got on-prem. Now, scalability, they have more hardware there than you have in your data center. Unless you are your own, government, basically, they've got more spare capacity. So if you're in an environment where you need burst capabilities, it's great. I mean, many, many years ago, I actually worked at the Omaha Performing Arts Center, Holland Center. There were about 4 different occasions where if we had the ability to spin up some really, really big web servers for a couple of Broadway on sales, would have been phenomenal. Would have absolutely loved that. And then as soon as the on sale is done, do you need $5 million worth of equipment sitting there for the same sale next year? No. In the cloud, spin it up when you need it. When you're done, spin it back down, save the money. That scalability is better than anything you can get on-prem. And automation, talked a lot about that one. Another one that a lot of people don't really factor in is key staff have more time to be proactive with these systems than they had before. I wear a lot of different roles in my world. With cloud, I don't have to worry about a network cable failing. I don't have to worry about replacing a hard drive if something hiccuped. These things are built in to be resilient and recoverable in the cloud. They still may have an outage here or there, but they're going to recover. It's just a matter of how long is it going to take. So if you're in the cloud and you do it right, and I stress that, you may actually have more time for your staff to start to be more proactive, to start to tune things, monitor things, look for inefficiencies. That goes a long way with the operationalism of this stuff. And then a big one for the C-level is the financial model shift. Now, if we're on-prem and I've got, let's say, SQL servers in a VM environment, you've got SAN, network, rack space, physical machine, VM level licensing, SQL licensing, Windows licensing, and you have to put all that together. And most of the time, you're not buying this all at once. But let's just say for poops and giggles, you are. You're spending a lot of money once every 5 years. You're financially amortizing it over the next 5 or 6 years. That's a lot of cash. In the cloud, it shifts from a capital expenditure model to an operational expense model. And you turn around and you're now paying basically by the second to basically rent the compute. That is a big shift, and I find that a lot of organizations love it because it means they don't have a big expense every so often, but other organizations hate it. They love to be able to write off the books a really big expense and then financially amortize it over so long. And there's no in between there. They either love it or they hate it. It's just interesting. And then my number one fact around cloud: you as a company are probably not a data center colo. Is it in your organization's best interest to have staff and equipment and licensing and knowledge and on-call to manage a data center when somebody else can do it for you? And this may mean regional colo. It may mean a managed services group. It might mean cloud. But you as an organization, to me, should be using the applications to power your business and not necessarily sitting there around the clock babysitting it. And I'm picky about that. Me for my business, my production is all in the cloud. My lab is in a 6-foot tall stack of equipment in the next room. It works pretty well. Question 2 here. Take a sip here. Question number 2. How do you want to use the cloud? And again, this is more from a data professional perspective because there's a lot of different things that you can do with the cloud, specifically around, let's say, Microsoft SQL Server, or at least Microsoft Data Platform. It certainly isn't always in, all in all the time. We got to go drop everything on-prem. Understand the offerings and what you can do from the Microsoft Data Platform perspective, and begin to define a migration of how you're going to use this. Define the strategy of how you're going to get there and how you're going to use it. Now, some people start small. We have a number of organizations where we've helped them use cloud storage just simply as an offsite means for backups. Most of these were smaller or mid-sized shops. They were, some of them, no exaggeration, were just putting USB drives in the trunks of their cars. Not cool. We've got other ones where they were maintaining, like a Datto device or something like that and replicating somewhere else. Other ones, they didn't have anything. What I'd love to do, if you're just treading the water in the cloud, replicating virtual machine backups, database backups, the important stuff, it's at least in a recoverable state. You may have to copy it back down, or you could spin up stuff in the cloud if your primary site were to have a problem. But it's powerful and it's cheap. We helped a company just as about 2 years ago now. We set them up for offsite storage onto the Azure platform. It was like $70 a month for everything in their entire business. And then we turned it on, make sure everything was working well, forgot about it. Last December, they got hit by ransomware. Entire company went down. The only device in the entire company that was not affected were the backups on the cloud. That saved their entire company. It's pretty amazing. If you want more speedy recovery, You can replicate for, a hot standby, warm standby, cold standby, software as a service. Have it sitting there ready to go. This is almost always cheaper than do-it-yourself disaster recovery. A lot of times people will have, another SAN or a NAS or some big device at another location, and they have to deal with an MPLS circuit and all this other stuff. It's not cheap to go do that. Me personally, I have 105 terabytes of data on the Azure cloud and about another 30 on Amazon. You know how much it cost me for the whole thing? $85 a month. I'm happy with that. I'm quite happy with that. If I were to try to do DR for the amount of storage that I have in my basement, it would run me probably $1,000 a month. I'm not willing to spend that. The next one, burst scalability. So cloud moves faster than your IT department, guaranteed. Unless you work in an environment more complicated than anything I've ever seen, they are running at the speed at which they can click. They have no good automation, just to be frank. Use the cloud to scale outwards if you have the right application architecture. So let's just say you've got a bunch of stuff on-prem, but I now need content delivery for my website. I can use a cloud-based CDN. Let's say I need reporting. I may be able to actually get a copy of my data and stream it up to a reporting platform in the cloud. People access that. It gets that off of my main servers, and then I can scale it up as high as I need depending on the demand. Maybe I scale it up for the first couple of the days in the month when people are running reports. Scale it back down when you're done. That amount of scalability is really powerful because you can minimize the cost and maximize what you get out of it when you need it. Scale it up to the cloud when needed, scale back. That example of the Performing Arts Center is very powerful. I wish I had had that, but that was, 15 years ago. Now I sound old. The specific services go in the use case. If I've got legacy code and I need certain bits of data flowing, I may be able to use data lakes. I may be able to use Azure Data Factory to pump data and transform it between different systems. I may have automated mechanisms to integrate to different cloud services, things like that. This is going to be more scalable, a better performer, and arguably less complicated than if you try to wire this stuff into your system yourself. Data lakes, I can pump in tons of data of dissimilar types and query them as if they were one set. Really extremely powerful. Reporting workloads, I've got scale out reporting. Azure SQL Data Warehouse is fantastic. There's just tons of good stuff. Power BI is out there. And all this you can just use. You don't really have to worry about turning it on, installing it, making sure it stays running. The machine learning piece is really cool. And this is something I've just started scratching the surface on. I've got a data warehouse in my lab with 35 billion perfmon data points in it. And I'm starting to try to learn how to use machine learning so I can spot anomalies in there. And that's going to be kind of fun. But again, I just get the data into a format that the Azure machine learning services can consume it. And then I just use it. I don't have to worry about setting up a machine learning platform. I just don't have the patience for that anymore. I just want to use this stuff. Or something else that we do, we can actually leverage geoscale data in the cloud. Cosmos DB, if you've ever played with MongoDB, things like that, just a good NoSQL database, Microsoft has this thing called Cosmos DB. It's got what they call different APIs in it. So it's actually got one that looks and feels and acts just like Mongo. There's another one, it's a document store. There's another one where it's table-based. The one that I love is just a basic NoSQL scale-out platform. We can collect perfmon data from servers all over the world, pump it to the nearest Cosmos DB endpoint that we've defined near them, use that as a shock absorber, and then we go collect it once an hour. That way, I don't have to build a SQL server that can ingest data from 100,000 servers, with right out of the bat. I did the math on this. This architecture saved me is 121 times cheaper to do this for the scale that we're collecting on versus building a SQL server that was built to handle that amount of writes. So I mean, we're talking tens of thousands a month, and now I'm talking hundreds a month. That's cool. Or if your organization truly is all in, great. Is this, literally, are you done being your own data center provider? I'm comfortable saying that. I don't have the patience to build and maintain this stuff anymore. So move it all. Get it out of there. But what is needed to move this stuff? And it's a loaded statement because some things truly are better suited on-prem. We work with a lot of different customers out there in a lot of different industries, and there's one, manufacturing space. We've got a couple of them. They are completely in on the cloud, and then we found that the latency to the cloud, and they're pretty close to the Chicago area, the latency was enough to hurt their business. We ended up having to run local print servers and local endpoints for a lot of their warehouse scan guns because the latency to the cloud and back was so high, it was starting to slow them down. Everything else that they've got is in the cloud, and those little devices act as relays to get it to the cloud. But they just couldn't handle having the primary source that far away. It was interesting. And then it's not just the data, it's not just the app. How are your users going to use it? How are your endpoints going to use it, your customers, things like that. There's a lot that has to happen in order to move this stuff. Now, one thing I always bring up here, Azure Arc, I mentioned it a minute ago. Keep an eye on this, start to play with it. It's really, really cool. Think all the power of the automation layers in the cloud, but then just pick your own data center. The investment that you've got in that on-prem platform, either now until it ages out, or you need to keep some of this in-house for some reason, I can now use the cloud automation to go and do this in my own data center. And it's super cool. In fact, today they announced that Azure SQL Managed Instance Preview is now enabled in Azure Arc. So you can actually update that and actually get managed instances in your own data center now. Really, really cool. It gives you a single control plane to be able to deal with all of this stuff. And if you need to move stuff in and out, really, really handy. And this is something that I've always felt that cloud should be a hybrid approach. Use the right location and the right tools for whatever task you're trying to achieve. To me, this is awesome. I don't know about you, but if you want to read up more on it, there's a link to the Azure Arc website here. Go check out the Ignite sessions going on this week. There are a handful of announcements around it. And then actually, if you look at our company Twitter feed from just an hour ago, I put out a link out there about the SQL Managed Instance updates. Number 3, what cloud database components can you use and which ones do you actually need? And this is one that you're going to want to work with your database administrators on, because what they might tell you may be different from what they need, which may be different from what they want. And that's a loaded statement. Do they just need a simple database? Or is it a little more complicated, where you may have something like SharePoint or some of these ERP systems that may have, an auditing database and a sessions database, and they have to go together, and that just won't work with an Azure SQL DB. So maybe I need to go get this out there on a single instance, or maybe I have an application server that's got some not so good coding practices, some of which maybe we can fix, some of it maybe we can't. Maybe it's a third-party vended app, and they just won't work with any of these other platforms. Maybe I just need a virtual machine out there, and it means you get all the features, everything that comes along with the platform, and all the negatives like patching and all that kind of stuff. So let's start small. Database as a service. So this is Azure SQL DB. And if you notice here, this is actually one that we use underneath a little consulting management app that I wrote. Nothing too fancy. It is quite literally just a database. You get no bells and whistles with it. We have no reporting. We don't even have a SQL agent job scheduler, but you do have Azure Runbooks. You can use that. You have no operating system access. You have no SQL Server instance access, but that's okay. I don't need it. I just need a bucket to put data, and it just needs to be there and run as fast as I need it. I don't have to engineer availability anymore. I don't have to deal with an availability group or a failover cluster instance. I just turn it on and use it. And if it becomes more critical, where if there's an outage, it needs to get back up right now, I can actually pick a criticality tier. General purpose is the regular one, or business critical. DR, I say I want to replicate this to somewhere else. It pulls up a map, you hit click, and then it replicates as long as you whip out your credit card and authorize it. If I need more than one of these to stay together, and there are a lot of applications that need this, I can pick a platform as a service. So Azure SQL Managed Instance or Amazon RDS for SQL Server, I get a SQL Server instance as a service. I get no underlying operating system access. But you know what? I'm fine with that because I'm tired of dealing with that. You get multiple databases, you get the agent job scheduler, you can send emails, you just don't have operating system access. So for most of the cases that we deal with the cloud, managed instance is really the right approach because I can just back it up, restore it into there, and it's just going to work. Availability works the same way. You've got criticality tiers, either standard or regular or business critical tier. And other than that, it's just a SQL Server. It just works. Or, like I said, if you need everything, SQL Server and a VM, you have full control. This really is just business as usual at this point. You have to patch it. You have to deal with the high availability if the platform and the tier that you've picked in the cloud isn't good enough. DR in the cloud can get easier, maybe. You can back it up over to Azure Blob. You can do replication out from that. So it gets a little bit easier in terms of turning the stuff back on, but you still have to design it. Backup replication, you can have fun backing the stuff up directly to a URL. And for all of you not so data professionals out there, you can in fact name a database as an emoji. And this is completely legitimate syntax. Most DBAs laugh pretty hard when they see that one. So if you ever want to shock them, create a database of a smiley face or something and watch them do a double take. It's kind of fun. You can do full backups, differential backups, transaction log backups directly over to Azure Blob. You can replicate it out from there. You can keep it around as long as you need. Blob storage is pretty cheap. It just works. It's highly available. I'm fine with that. The hard part here is if this is the only form of backups that you're doing, if the operating system goes corrupt, because let's say, a failed Windows patch or something just hoses the machine, you need something to restore the databases into. So keep in mind that you do need to run some sort of backup level protection for the OS volume. Any questions so far? Okay, cool. So the next question is, what are your availability requirements? And I'm gonna pause here for a second. There is a rift right now between database administrators and people that manage the infrastructure. Infrastructure usually backs up data nightly. From a DBA perspective, the demands that the business places on them is such that if the poop hits a fan and something goes down, you have immediate availability, immediate recoverability, and no data loss. And what that means is the platform architecture for backups doesn't necessarily match the availability requirements from the business for the data. So this is something you may have had discussions or arguments with your DBAs about over the years, but this is something that understand all the perspectives of each role and understand the perspective of the business. So when I talk HA and DR, this is data specific and not necessarily just regular app server. Skip the technology, step away from the keyboard and go talk to the C-level. You need them to define two terms for you. What is the recovery point objective of a mission critical database, or RPO? What that really means is if the poop hits a fan and this thing goes down, how much data can the business afford to lose, usually in terms of minutes or hours? The next one is the recovery time objective, and that's RTO. If this thing goes down, how long is at most can this thing stay down before the business starts to have problems? So how soon can you get it running? Throw away the technology, skip all of that. Have them define these values. That's what you're going to engineer your architecture for. And I may seem jaded with this, and I'm actually about to relaunch the SQL Server HADR virtual chapter online, similar to the user group here. A company's owner may tell you one thing, and they'll tell you, but they won't put it in writing. And they'll say, yeah, it's fine. We can be down for a day. We'll manage. The second something really goes down, they're going to be the guy behind you with a baseball bat saying, when is my business back up and running? I've seen this personally at multiple organizations. They had no defined SLAs. They had basically a handshake that said, yeah, we can get it back up soon. The second it goes down, they change. Their business is down. They feel it from everybody. What I love to tell people is that you step away from the keyboard, you have them define these two values, and you work with them until they understand the implications of this. Put it into an agreement, print it, and have them sign it. That's what you're building your organizational SLAs to. If the poop hits a fan and you have to exercise this, you have that document that said, I have built my architecture to meet or exceed these two values. That is protection against a resume generating event, in my opinion. And I know I sound like I'm preaching with this, but I have seen multiple occasions where the SLAs, no exaggeration, 1 day RPO, 4-day RTO, the poop hit the fan, and after 20 minutes, they were screaming, and 2 people got fired because it took a day to get everything back up and running. So be careful with this one. These SLAs are important, and here's why. If you've not dealt with a database level backup before, I can do a backup of what has changed in the database periodically throughout the day, and I generally do with all the systems that we design. So let's just say that the business, they didn't tell me this, but they gave me an RPO of 15 minutes and an RTO of 1 hour. Now, me as a DBA, I'm going to be fancy. I'm going to do a 30-minute transaction log backup because they didn't tell me the memo. They didn't give me the memo, and I don't know what they were thinking. So here's how I set it up. 12:45, a transaction log backup occurs. No problem. 1:12, I had a cascading failure in my storage device, and it went down. 3:55, everybody pulls a Hail Mary. It's back up and running. Okay. The difference here, almost 30 minutes, that is observed data loss. That data is gone. This amount of time here between 1:12 and 3:55, that is your recovery window. Your SLAs, your recovery goals were only 15 minutes and 1 hour. Not to scale. You just breached your SLA in both ways. That's not good. I have seen companies make multi-million-dollar guarantees to their customers about outages that wouldn't happen, and then they happened. This is why everybody has to be on the same page from those two numbers, and then you can design your architecture properly. Once you have those, with the database service in the cloud that you're planning to migrate to, quite literally, they tell you, general purpose, business critical. There are SLAs documented at every major cloud provider for every major service that they will meet or exceed for these different pieces. For example, Azure, I believe general purpose is 99% uptime. Business critical, 99.9% uptime. Doesn't sound like a big difference, but a 99% uptime means we could have a 3.5-day stretch a year that thing is down straight. If you have a 3.5-day outage, you're screaming bloody murder, and they're going to go, but we met our SLA. That's not cool. Business critical, 99.9, it increases that and makes it better, makes it higher, meaning less time down. The availability targets are one that's really interesting. So let's say you've picked a platform, but your availability requirements as defined by your business is more strict than what the platform gives you. This is where you have to turn around and work with everybody, C-level, other IT people, cloud provider options. Do you have to re-review your choice, or can you complement that layer of the cloud platform with a high availability solution of your own to make it better? You may overcomplicate it. No, you may complicate it. I'm not going to say overcomplicate, but it may be better. So an example of this is one that we have to do a lot of, unfortunately. They need a virtual machine in the cloud to run a database engine. They have a lot of goofy architectures for this. The SLAs are not good enough, so we will run a SQL Server availability group inside the cloud virtual machine. So each piece of this has their own SLAs, but the combination of them with the proper architecture means we can get a lot better guarantees out of this thing just because of how we design it. Feel free to go and pick and choose. The good thing about the cloud is you have a lot of options. So if it's not good enough, either change your expectations or see if you can complement it with a design of your own. Okay. Number 5, what are your security requirements? And I ask carefully because from a DBA perspective, we have a lot of different sorts of data. I mean, today alone, And that was 8 a.m. to about 5:45 p.m. I was working on 2 systems that contain credit card information. I had 2 other customers that have healthcare information. I'm on systems with medical records, bank statements, travel plans, things like that. What kind of data does your organization have? What of that would you consider, a front page news making event if that got out? If you're a shoe sale, you still probably have credit card information. If you're a bank, you've got a ton of financial info. What kind of regulatory compliance is your organization under to maintain the safety and security of this data? And that's a really hard one. Some people have PCI, HIPAA, SOX. All of us are under GDPR. This is a big deal. We need to really realize, what are we subjected to? Who needs access to this stuff? And again, I go nuts when I see organizations where this stuff is wide open. An example of this, I've got an airline that's a customer of mine. The act of getting data from a database to an application server traverses 5 firewalls. And while that might be slightly overkill, I totally get it. Quite frankly, your practices on-prem are poor. Most things are wide open until you lock it down selectively. And this is why things like ransomware or permissions changes and now everybody's got access to all this stuff. This is why it's such a challenge. Cloud really is just the opposite. And I would claim that cloud is inherently more secure than your on-prem. But that's with an asterisk. And I always ask, RTFM, can you read the funny manual? And don't Google that on a work computer if you want to know what the F really stands for there. If you do a little bit of Googling around things like Amazon S3 cloud bucket breaches, things like that, people don't read the manual all the time. They leave these things wide open because they're too lazy to secure it properly. And you can end up with a lot of critical data that's just wide open to the public, and they will find it. So keep an eye on this, read the manuals, follow the practices to secure this stuff. If you do that, it's, in my opinion, more secure than what you get on-prem. Most things are exposed. Cloud, lockdown. The big challenge with this is now you have to have a map. What talks to what? And I do a lot of database migrations. Did one this past Friday night. I counted no less than 61 endpoints that were independent of each other, all calling the database for data. They had none of it documented. It was a real chore because I had to open up firewall ports and rules from each of these individual application servers to get and expose the data to these individual servers. You need to have the stuff documented before you think of a cloud migration, no matter what platform you're looking at. So it's literally, what's talking to the database? What ports does it need? What level of security does the login that it uses to get the data? What should that have on it? You got to have this stuff mapped out. Otherwise, we're all human. We're just going to open it up. That doesn't work in the cloud. Number 6, I could spend the rest of the night and all day tomorrow on this one. How much performance do you need in the cloud? Now, I'm a performance tuner by trade. I love this topic. I'm not going to bore everybody to death here, but I will tell you that the performance demands in the cloud are way different than what you get on-prem. And I'll tell you why as we go through. So step number 1, do you have a good baseline? In on-prem, in the cloud, whatever. Do you have a baseline of the resource consumption patterns of what your servers are doing today? And if you're nodding your head, yes, great. And I'm going to ask you a question that's going to make you question your response there. It's 7 o'clock on a Wednesday night. Within 10%, what's your SQL Server CPU doing right now? If you can answer that, the next time I see you on-prem, I will buy you a pizza. How's that? If you don't have a good baseline, not only do we not know how much compute resources to allocate to our cloud object, but you don't know if it's healthy or not. That's tough. Some third-party utilities can actually do this pretty well. From a Windows perspective, if you don't have one, you do. It's built into Windows called Windows Perfmon. Go out to our website here. There's no contact info required. It's just a PDF. This tells you how to set up Perfmon for ongoing 24/7 collection. That's powerful stuff. Now, everybody on the internet tells you to go collect Windows perfmon. Nobody tells you what to do with it, right? Well, out at GitHub, we have a script out here. If you're a little fluent with perfmon and PowerShell, you can collect this on a bunch of different servers, run this PowerShell script, and it will load it into a SQL Server database. We can now turn around and figure out, what's it doing on a normal day-to-day basis? What analytics tools do you like? Those Tableau, Power BI, T-SQL, Excel. You have the data. Go mine it and start to figure out what resource consumption do I actually have on any of these servers. If you're already in the cloud, do it anyway. You might be over allocated. Anytime you downsize a server in the cloud or a service, you're saving money literally from the time you click go. Or conversely, if it's running slow and you can objectively prove that it needs more, that'll give you the ammunition to go get the budget to grow that service. These KPIs are straightforward. Make sure you have a reasonable collection granularity. I usually choose every 30 seconds and then roll it up accordingly. You can get some really interesting results like CPU consumption by core. The SQL Server layer will actually shield its memory consumption from the underlying infrastructure. So VMware, Hyper-V, Windows even, they get the memory consumption patterns completely wrong. You get into the database engine, you can go grab this here. There's a lot of counters like page life expectancy, memory grants pending, buffer cache hit ratio. There's all kinds of good stuff in there that will give you what the database engine is actually using. Storage or memory in the database engine is nothing more than a storage read cache. Working set data goes there and it holds on to it so it doesn't have to reread it from disk. If my memory footprint is pretty good and I'm not churning too much, maybe I don't need as much storage speed. And it works just the opposite. Now, if I do need this, especially for writes, what amount of throughput do I need to disk? What amount of IOPS do I need? What's my SQL Server workload look like when I've got caps on any of these things? You would be amazed. This is, in my opinion, the worst case scenario that I've ever seen with an imbalance on the virtual machine and the Windows layer and the database layer. This was captured on-prem on a VMware environment. Somebody had misconfigured the virtual machine. This was a 16-core SQL Server. When I got on and took a look at this, 8 of the 16 cores were absolutely freaking out. This was a 9-to-5 shop. They didn't do anything during the evenings. They didn't do anything on the weekends. And this thing was active the entire time. That's not cool. That's not healthy. This is what happens when we tuned it. It dropped way down. Now, I'll give you an example of what we did with this. If they were on-prem, how we fixed this, they had built the virtual machine layer for 8 virtual CPU sockets by 2 cores. Windows Standard Edition and SQL Server Standard Edition have a license impact that says they can only address up to 24 cores or 4 sockets worth of CPU activity. They were going to move this to the cloud. They were like 2 weeks away from doing this. Got into VMware, right-click, shut down. Right-click, edit VM, go to CPUs. We dropped it to 8 cores at 1 socket. Problem disappeared, thing leveled out at 15% busy. We dropped it down to 4 cores after that. By the time we were done, the speed of the database engine went up by 3.5 times, and we had plenty of headroom at just 4 cores. Saved them $1,400 a month in 4 clicks right there on the spot. They were happy. Same kind of thing. This particular SQL Server, this is an 18-core SQL Server. The DBAs, quote, knew they needed all of these, and they were asking to go up to 32. Run a baseline. Let the numbers dictate where you go with it. They had 18 cores. Most of them were functionally idle. Of what was active is like 4 cores at a time, maybe. You could downsize this thing to maybe 8. Probably even less, and it'd be perfectly fine. The numbers dictate a lot with this stuff, and visualizing it goes a long way. So being able to take that perfmon data, look at it objectively, and step back and just say, where are we at? This is just nothing more than Excel. You can do this. When you're on IaaS in the cloud, you select the series. So you select the CPU scale, the CPU architecture, and the amount of memory. Every one of these series has a CPU type that comes along with it. You can actually run some numbers and figure out if the individual CPUs with the different series will buy you a pretty decent performance gain, and some of them will. Like Azure E series, if you're CPU starved, per core, it's about 30% faster than what you get on the D series. You pick the series and the scale. So in this case, let's say the one that's selected, 8 cores, 56 gigs of RAM, you get 112 gigs of temporary storage with it, a little over $4 an hour. It adds up, but you get what you pay for. Then you attach disks to give you your storage, and you can pick the architecture that you want, either cheap capacity or decently fast or really fast. Just get out your credit card. If you're on database as a service or platform as a service, most of these are on a virtual machine core model. So this is a managed instance. And I can say, give me a managed instance at 8 core. RAM comes along with it. Usually it's about 6 gigs of RAM per core, roughly. And then configure the storage space as needed. There's less customization with the X as a service models here than there are with the virtual machines. But quite frankly, if it's good enough, who cares? It's just simply less that you have to go manage, right? So in this case, I need a terabyte of RAM or of storage underneath this thing, $256 a month. Not a big deal. Okay, number 7. How are you going to migrate your data? So let's assume we've now picked the service that we want to use. We know the scale because we have a baseline. How are we going to get it there? These different platforms may not be as simple as a backup and restore. I wish it was. I wish some of these were easy. If you're going to a virtual machine with SQL Server installed in it, yeah, you just copy it up and back it up and restore it. If you have the time. What if your migration window is very short? And no exaggeration, I've got one system, 741 terabyte single database. We've got approximately 4 petabytes of all flash in an on-prem data center. It still takes 12 hours to back up. That's ridiculous. You try to migrate something like that, or even let's say a 2 or 3 terabyte database to the cloud, your outage window is going to be massive if you don't have a high amount of bandwidth and you can't back this thing up quick enough. So sometimes it's fine. Sometimes you may need to do something like database level log shipping or detach, attach, or mirroring, or stretched availability groups, or heaven forbid, transactional replication. These things kind of work. If it's a small database, Microsoft gives you the ability to basically script everything out. It's called a backpack. If you're just looking at scripting out the schema, so the table and the objects, but not the data, you can do a DAC pack. Where they came up with these names, I'll never know. If you're looking for something a little bit more modern, there is a thing here called the Azure Data Migration Assistant. It can help you with this. It's actually pretty slick, and it becomes more automated where it'll get the destination in sync and it'll keep it there. You just have to make sure that you have a persistent connection between your on-prem data center and the cloud and poke some holes in your own firewalls to allow it in. If you're going to a managed instance, backup and restore can work from Azure Blob. You can also do a DAC pack or a backpack export and import, or use DMA, and it works well. Now, Azure SQL Database, we're going to call this one the red-headed stepchild. You can do a backpack export and import. You can use the Azure Data Migration Assistant. You can use kind of a fancy version of this called the Azure Data Migration Service. Again, it basically will just work where it just pumps data in, keeps it in sync. There is no restore of an on-prem database into an Azure SQL database. That's a problem. That's actually why a lot of people elect to use a managed instance. So keep that in mind. It's not as easy as it seems. The other problem here is, let's say I want to move my data out or do things like take a production database backup and restore it to a dev environment for my devs to get access to once a month. This becomes a problem. If you're on an Azure SQL database, you cannot back this up into a regular SQL server. You literally have to extract the database design and the data out if you want to get it back to a regular SQL server. There's some tricks in the cloud where you can take snapshots and you can clone it, and you can refresh it to another SQL database. But that's it. You literally can't get the data out unless you pump it out. You can also not back up from a SQL Server managed instance in the cloud to a regular SQL Server. It's really just a SQL Server in the cloud, but Microsoft's strategy is cloud first development, and then periodically they'll package it up and get it to you from a box product perspective. The metadata inside the database is newer than what you have even in the most current SQL Server engine. Because of that, if you were to copy a backup from the cloud down to a regular SQL Server, you can't restore it. So you have to restore it into another managed instance, but that is portable. That does work just fine. So little constraints to think about. This may actually mean that if you want to use an Azure SQL DB, but you want to have an archived copy of the data for regulatory compliance, you're at the mercy of a cloud database backup on that platform, and it becomes a little bit more tricky to go hold on to this and use it when you need to down the road. So stuff to think about. Number 8, and this is one of those topics that if for the people on the call, if you've never had to deal with SQL Server licensing before, more power to you. There's a little spot of gray right here that has probably come from just dealing with licensing. This stuff is not fun. How are your database engines currently licensed? And this is a really loaded statement. Most of the time, not even the DBAs know. Most of the time, this is a CFO or a financial controller, and they've got a lot of this. Your CIO should know this, but sometimes they don't. Understand how you're currently licensed, because there may be some options to cut your cloud cost if you have licensing that can transfer. This is a big deal because there is a thing out there called the Azure Hybrid benefit. If your SQL servers have something called active software assurance on them, you do get the ability to basically lift and transfer your licensing to certain objects and certain scale in the cloud. This can save you a lot of cash, because most of the time I find that software assurance on-prem, after you've paid for the initial product, is a lot cheaper than just rebuying the license in the cloud. You do have to have this. There's a really, honestly, there's a really dry document out there. It's the official SQL Server 2019 licensing guide. It lays all this out for you, but the hybrid benefit is pretty good. Not only does it give you the ability to transfer this stuff to the cloud, but if you've got active software assurance today, you can have DR-specific licensing that applies to the cloud, where maybe I'm using an availability group and I can actually run this for DR-specific licensing in the cloud. So that way, if, again, the poop hits a fan, I can fail over to this thing quick and it works. Run the numbers ahead of your migration, please, because it's expensive. Right size your destination. The difference between a 4-core Enterprise Edition SQL Server and a 16-core SQL Server in the cloud is probably about $3,000 a month. Understand what you need. Don't trust the vendor. Don't trust, I think we need this. Use the numbers to dictate what you need. Leverage the Azure Hybrid benefit and migrate this stuff accordingly. Review the DR-specific licensing clauses. If you're under active SA, you really may be able to run DR out there at a really reduced rate, which is really powerful. Now, take that and now figure out your monthly cost. And this one is tough. I'm going to be careful with how I say this, but there are a lot of myths in the cloud, just like I've already mentioned. The biggest myth that I find is that cloud services are pay for what you use. A lot of them give you the analogy that it's kind of like a power grid connection to your house. You pay a little bit per month to have the right to draw power, and then you pay for what you consume. Some things in the cloud are like this, like Azure Blob Storage or DNS lookups or load balance activity, things like that. Other things are not, and unfortunately, literally, Amazon, Microsoft, whatever, the cloud data services, for the most part, are not pay for what you use. It is pay for what you allocate. This is a big deal, because if I allocate, let's say, an 8-core Azure SQL Managed Instance, and then I just forget about it, you're still paying for it. That's not cool. Literally, this guy right here, 8-core Gen 5 Azure SQL Managed Instance, estimated cost $2,241 a month. If I'm using 10% of what this thing can do, I'm still paying those. This is where right sizing comes in, because The cloud allows an IT professional to bridge the technical gap and actually get to a whole different layer of the organization, and that's the financial side. If you can prove to your organization that I have right-sized this, or even better, let's say I'm tuning the platform and I've done query tuning and index optimization, and I cut my CPU consumption down by 40%. Maybe I could go down to a 4-core managed instance, cut that price tag in half. Save that for your annual review and just say, look, I right-sized this in March, and between March and the end of the year, I cut this in half. So I saved you 10 grand. Can I get half of that as a raise? And can I get to go to some of these conferences next year? You'd be amazed at how much benefit you'll get if you can objectively show them, not just speed or numbers, but give them the benefit, the business benefit of this stuff. And I had one company out there, no exaggeration, we downsized and saved a ton of money, and all in the cloud. And their IT, their DBA team lead showed this to the CFO with the CIO sitting next to him. Guy got a $20,000 bonus the next day. That helps. That definitely makes the holidays better. Now, the factors for sizing here, this is where things get really interesting. When you're looking at the raw numbers on there, estimated CPU and your memory footprint, honestly, are the two biggest draws behind what you're actually getting dinged on. Focus on separating out business hours from peak hours. What if my peak consumption of CPU is at 2 a.m. when I'm running database index maintenance? What if it runs in 30 minutes and it spikes the CPUs all the way up? But what if I have 4 hours for this to run before a single user actually gets on the system? If it takes twice as long to run, does it matter? It might not. But what if that's the peak CPU consumption during the entire day? So if I monitor that, cut the scale of the VM down, it'll take a little bit longer. So what? You save money, nobody else knows the difference. Keep an eye on it in case that maintenance grows, but that's a way to save some cash. Also, the amount of memory. If you look at the cloud sizing, sometimes just the amount of memory, even if the core count stays the same and the memory increases, that's enough to jack up your cloud costs. Same thing with storage speed. If I can do tuning of these different things, and it could be query tuning, could be index tuning, I can cut down the demand on storage. And if I need a good amount of capacity, but it doesn't have to be quite as fast, maybe that's a difference between a premium SSD and a standard SSD. They're both fast, but one's just twice as expensive as the other. Then storage space. Talk to your company about archiving certain data. Everybody hates deleting data. I got one. They have 21 years of financial data in a database. Their CFO needs the last year. Their CPA firm needs the last 7. Do you need the other 13, 14 years? No. Do you need it around for historical purposes? Maybe. Get it out of the primary database. Put it on something super cheap and archive it. You can pull it up when you need it. Bandwidth is another one here. Application servers and database servers can send a lot of data between them, especially if you're doing BI type workloads. Factor this into your cost. It's usually not that much, but you can use Perfmon to track the data flow between the machines and figure out how much you actually need. Usually it's, 1% or 2% on your total cloud bill, but occasionally it adds up. Same thing with DR. DR depends on how you do DR. You might get charged for the storage. If you need stuff that's hot and sitting there waiting and receiving data streams, then you're going to get charged for the compute time on that as well as the bandwidth. Factor this stuff in up front. The Azure calculator can help you out a lot with this. The link is right there. It's nice and straightforward. You pick the cloud service. So in this case, we're going to say, I need a VM. Windows operating system, OS type only, standard tier or basic. Instance type here, it's a DS13 V2, so 8 CPUs, 56 gigs of RAM, 1 VM, 730 hours per month. We're going to just double check pay as you go. License is included with this, $770 a month. There were a couple terabytes of managed disks in this quote. Monthly cost $944 a month. Okay. Add a SQL Server into this. Bring the licensing with the virtual machine price. That jumps to $1,500 a month. Okay. Now go Enterprise Edition. That doubles the price. The interesting thing here is that Enterprise Edition on-prem is 4x the price of Standard Edition. In the cloud, it feels more like 3x. I think they're trying to get people to move to the cloud, don't you think? Kind of interesting. But now, look at this at a micro level. How many compute resources does this machine actually need? How much storage does it need? How much storage speed does it need? And then zoom out a little bit. Start to run the numbers. We had one environment that they were looking to lift and shift everything of the 118 SQL servers. Their CFO realized that a 5-year cloud spend was going to be about $11 million. Their on-prem platform to power the whole thing was $600K over the same time span. That's a problem. We went in, all we did was right size them and just say on 118 SQL servers, I think it was 111 of them could have been cut in half. The others, they needed the allocations, but then we realized that their licensing was such that it would have transferred and they didn't realize it. So we ended up saving them a bunch of money, transferred the licensing up to the cloud, and everything was good. Run the numbers ahead of a migration. Make sure you've got buy-in for this, because the absolute last thing you need is you migrate to the cloud, the migration is a smashing success, everything's running great, and then you get the first bill. And then it's just like, the record scratches at a bar or something, everybody turns and freaks out. It's not very fun. Serverless can be an option. From the data platform, they call it serverless. All it does is just throttle back the data platform. You have a minimum core and a maximum core allocation on there. And when the database engine goes unused for a certain period of time, it'll actually throttle back the core count to the lowest one. This can save you some cash if you're on an Azure SQL database. This does not apply to a managed instance or a VM. There's the serverless. You can get to it in the compute or in the calculator. You set a maximum number of cores, minimum cores, and then an average amount of cores used with the average amount of memory on the seconds in here. And we do this sometimes for dev machines, things that they're running during the day, but nobody's going to touch them at night. We can scale this thing way down, scale it up during the day, saves a bunch of money. Life is good. So, your build for the storage, no matter what, the compute is where you can do the savings on. So factor that in. Okay, last question. And we're all IT professionals. This is going to be the biggest loaded statement I'm going to make here. What are your future needs with the data platform? And I'm certain we all have magic crystal balls and we know exactly what the business is thinking for the next 10 years, right? No, doesn't work like that. What technical debt do you have that you have to work through? What are your space consumption trends? How much data is growing every month? What business changes do you know? I mean, I just got wind of this morning, another company that we work with bought another company. They've got 200 users that they have to add to their system here in the next month. Our data volume is going to spike as a result. What upcoming projects? What initiatives? What does the business want to do? Are you willing to archive some old data? What do you actually need? What can you get in front of to try to figure out? If you're on a SQL, Azure SQL database today, and somebody wants to add a separate reporting database tomorrow that may not work with your reporting architecture, you might need a managed instance. Be thinking about the stuff the best that you can. What known scalability limits are within your application architecture? I've got one application that we work with. They're trying to get to the cloud for their different customers, but they know that their biggest customer right now is really aggressive with some locking on some certain tables. Their database application design simply cannot handle, no exaggeration, half of a factor of magnitude growth. So if their user base is 500 users, they can't add another 250 and have the application server continue to work. They end up with snowball locking in there, which gets really bad. What design choices can you change potentially as part of a migration, or just what are known factors that can keep you from scaling the way your business needs? It's a problem. Same thing with all the technical debt, all the skeletons in the closet. We've all got it all. What do you know of today that may actually get in the way of some of these cloud migrations? And there's always going to be something. The question is, can we work through it? And then the last one, are these third-party vended systems? Do you want to deal with a lock-in on certain things? Will your application vendor fail to certify the platform if you move to a cloud platform? I've seen it before. They don't want to deal with virtual machines in the cloud. Some of them flat out refuse to do VMs on-prem. Still silly. It's a lot to think about. But this is basically about 8 years worth of cloud work where these are the questions that if we can answer up front, we can save a lot of pain. Cloud is one of the best tools that you as a data professional and a systems professional can put in your toolbox. It's not the right tool for everything. It is a fantastic tool when it's the right use case. Migrate for real reasons. Choose the data platform path carefully because you don't want to back yourself into a corner on this stuff and make more work than you might actually need. Understand the cost model. Please right size. On-prem, it makes it quicker, maybe cut some costs down. In the cloud, you'll save money immediately. Plan for the future the best that you can. And if you can do a lot of this stuff, it's going to run smoother. It's going to be more highly available. It's going to be, more cost effective. What questions do you all have?
I don't have any, but great session, David. I'll encourage people on the call, if you have any questions, feel free to unmute yourself and you can ask question directly to David. I don't see anything on chat though.
Cool. Yeah, there's a lot of stuff in there. I will say for anybody who's watching the recording after the fact, if you have any questions on here, feel free to ping me either on Twitter or on LinkedIn. I'm pretty easy to find on there. And if you have any questions that I can answer, I'll be happy to answer them. And if I can't answer them, I'll find somebody that can.
David, my CPU on a Tuesday night at 7 p.m. is 10%.
Cool. So therefore, whenever I find you next in person, you get a beer or a pizza or something on me. Yeah, these baselines they will make or break a good, well-oiled machine. And I'll just say, when I'm brought in as a consultant to try to fix stuff, and they always say it's running slow, I always respond. It's like, well, what is it doing when it's running well? They never have an answer, ever.
All right, good stuff. I think we are almost on time, 7:25. On behalf of the user group, I thank you, David, for taking your time and talking through this. It was a great session.
Cool. Yeah, thanks for having me, and thanks everybody for jumping on. I know at this point with everything going on, we're all getting a little bit of Teams and Zoom fatigue. So thank you, and thank you for being a part of the user group because it's with everything being virtual right now, it gets a little isolating for all this. So it's kind of a fun way to kind of geek out with everybody.